Hello, welcome to MVPDays. In this session, we are going to discuss how to bring the Azure services to the far edge with Microsoft Azure Stack Edge. My name is Janaka Rangama, and I'm joined with my esteemed colleague Kris to present this session today. A little bit about myself. I'm a senior principal engineering technologist for the Azure Stack family of products at Dell Technologies. I've been a Microsoft MVP and an MCD for a couple of years now. I've written a few books and I lead a few communities here in Australia and in my motherland, Sri Lanka as well. If you want to connect with me, my details are on LinkedIn and Twitter on the screen. Now, I'm going to hand over to my amazing colleague, Kris, who's actually going to demonstrate today's live demo from his homestead while attending to his friends at the farm. Kris, over to you.
Thank you, Janaka. Hi, my name is Kris Turner, also known as the Country Cloud Boy. I'm an Azure customer engineer working at Microsoft. Today I'm pretty excited. Why? Because I'm going to show you how to bring Azure services like machine learning, stream analytics. Let me get that phone call. Azure custom visions, all to your Azure Stack Edge by using custom IoT modules.
Thank you, Kris. Now, before we start talking about the Azure Stack Edge, it's pivotal to have a little bit of understanding of the intelligent edge ecosystem in Microsoft product portfolio. On your left-hand side, what you see is the tiniest point of entry to this ecosystem, whereas on your right-hand side, it denotes the hyperscale cloud that Microsoft is running. So starting with things like Azure Sphere, which is a dedicated MCU that runs the Azure Sphere Linux OS for modern MCUs, and all the way up to the fully fledged Microsoft Azure cloud system. Microsoft provides a plethora of devices, capabilities, and services for you to bring out your applications to the far edge. Now, for sensors and controls, as I mentioned earlier, you have Azure Sphere and you have the Azure IoT device SDK enabled IoT devices that you can leverage, and you can generate the data and the telemetry you want to ingest into Azure. Then, if you want to work with things like interactive sensors, for an example, like drones and stuff like that, in that case, those things are considered as edge devices. Now, these edge devices has to leverage Edge runtime, which is provided by the Azure IoT Edge. So it allows you to deploy and manage Azure services as containers on any IoT device, literally. So some of those services are AI, Azure ML, Azure Stream Analytics, and there's more of these. Now, in order to process the data gathered from those sensors and controls and interactive sensors on edge devices, you need some sort of a compute or a platform to process this data. Here's where the Azure Databox Edge, Azure Stack Edge, and Azure Stack Hub is coming into the picture. Now, Azure Stack Edge, previously known as the Databox Edge, is an AI-enabled storage and compute Azure Edge appliance. So one new server provides you just enough compute to run those edge Azure services. Whereas the Azure Stack Hub, previously known as Azure Stack, is a cloud consistent edge. So basically it provides a large subset of services that is available in Microsoft Azure and is considered as an extension of Microsoft Azure. So scenarios like edge are disconnected, regulatory requirements, and making the cloud app model on premises would be ideal use cases for this product. And finally, you have the full range hyperscale cloud services with Microsoft Azure. Now, these services can be offered as tiered services, and there's a plethora of open source based services and tools with Microsoft Azure. Now let's move on to today's topic, the Azure Stack Edge, or previously known as Databox Edge. As I mentioned earlier, it's a single one-use server, and it is an Azure Managed Edge appliance that brings the compute, storage, and intelligence of Azure right to where you need it. What do you mean by that? Now I mentioned this is a one-use server, and inside that there's just enough compute for you to run those edge workloads. So some of those edge workloads are listed down here. So you can do things like hardware accelerated machine learning, you can use edge compute, and you can use as a cloud storage gateway where you can storage your data to Azure over network while retaining local access to the files you need. And of course, it's managed by Azure portal itself. Now, when we talk about management using the Azure Stack Edge, so couple of things to keep in mind. Now, when you want to order one of these devices, it's just easy as logging into your Azure portal and ordering one. It adds to your Azure bill, and it's you don't have any minimum period or hardware to purchase because Microsoft abstract that to your monthly Azure cost. Your configuration, access, and what workloads you want to run in these devices all are managed from the cloud. So you push that from Microsoft Azure. You can use the standard Azure management tools that you're used to now because it's considered as a resource in Azure which plugs into the standard Azure management tools and APIs. What are the use cases for this product? Now, as I mentioned, we are talking about taking Azure's edge capabilities to the far edge. So from a case study perspective and use case perspective, there are three main cases that you can use Azure Stack Edge. Machine learning at the edge, edge computer and IoT solutions, and network data transfer from edge to the cloud. I'm going to discuss about some of these and showcase a demo on how to use Azure IoT Edge and the other IoT capabilities at the end of the session. So when you want to run hardware accelerated machine learning with the Azure Stack Edge, it provides you a choice from NVIDIA T4 GPU or Intel Aria 10 FPGA. And you can use Azure Machine Learning Services or any other open source AI models. And it allows you to run inferencing and train your machine learning models at the edge with GPU processing. When it comes to edge compute, you want to run Azure services at the edge locations where there might be a proper data center location or not. So either these workloads will be either VMs or containers. And when you want to scale these compute workloads, you'll be scaling this across a Kubernetes cluster for performance and high availability. It's a cloud managed appliance, which you order from the Azure portal, like I said. And all the VMs, containers, and the workloads you deploy in Azure Stack Edge are managed in the Azure portal itself. And you use the same hybrid cloud management ecosystem with Azure Stack Edge to manage it. It can be used as a cloud storage gateway where you transfer your data from on-premises to Azure for backup, archival, or cloud scale processing. You can also optimize the data transfer using throttling and local caching. And when you have a network disruption, you don't have to worry because the appliance is aware about any disruption happening and it'll process once it restores the connection back to the cloud. When we look at the solution architecture of this product, as you can see, all your on-premises telemetry generating devices are connecting to Azure Stack Edge, which then filters out what data is needed and what is not and sends it to the relevant services in Azure Cloud. So you can run local edge compute, you can run local storage and hardware accelerated machine learning services, filter out the data you need and send it to the public cloud for further processing. Let's take a look at how Azure Stack Edge does the hardware accelerated machine learning. Now with hardware accelerated machine learning on Azure Stack Edge, it processes the data locally. Now where it is generated, the reason is to generate immediate results. Now these results can be used to act upon in the cloud or on local systems. So basically you can transfer or keep the processed data. So a good example would be if you deploy a trained machine learning model on an algorithm on an Azure Stack Edge. Now it can process the known data and send the anomalies back to Azure. So if it's an inferencing application, all the local inferencing results or the known results are processed immediately. It provides you two GPU options, with one with FPGA with Azure Machine Learning, and it's automatically accelerated on the FPGA. And for dedicated GPU, it provides NVIDIA T4 GPU, which is currently on a preview, and it supports Azure ML, Onyx, and NVIDIA EdgeX for things like DeepStream, TensorFlow, and much more. What about compute on Azure Stack Edge? Now, as I mentioned, this device is not a full-fledged computer. It's not your just VM dispenser. Rather, we are deploying intelligent compute on this edge appliance. So we can deploy things like Azure IoT Edge and use that to deploy and manage containers from Azure IoT Hub and integrate your solution at the edge. You can deploy Kubernetes clusters to scale across multiple nodes to provide a cluster of appliances so you can manage your workloads from cloud to edge. If you want to bring your virtual machines, just virtual machines, to the edge, which are not containerized, basically Windows or Linux VMs, you can do that in Azure Stack Edge as well. But bear in mind, this has a limited capacity, so there's a limitation to what sort of VMs you can deploy. So the Kubernetes and virtual machines at the edge are previews, private previews as of now, and public previews of this product is coming soon. Now, when we talk about the Azure IoT Edge, it provides Azure IoT Edge modules so that you can run Azure services literally on any device. Some of these services will be AI, Azure ML, Stream Analytics, Azure Functions, SQL, and bring your own code as well. It provides support for open source and Linux and an expanding set of OSs. As always, Azure IoT Edge is cloud managed. What you mean by that is it's managed by Microsoft Azure itself. If we look at the Azure IoT Edge deployment into the Azure Stack Edge, what's behind the screens? This is a sample example of the deployment, and during the demo, Kris will explain in depth how we deploy and manage Azure IoT Edge into Azure Stack Edge. Now, basically, what happens here is in the Azure Stack Edge, you will deploy the Azure IoT Edge as a containerized instance. Now, you'll pull the relevant containers from Azure Container Registry that is running up on Azure. The deployment manifests and the other containers, and you can pull things like Azure IoT Hub, some other Azure services like Stream Analytics, Machine Learning, and if you want any other third-party service like data conversion, and if you have custom code, that also you can deploy. So you pull the containers that contains the Azure IoT Edge deployment from the Azure Container Registry, and you send back the device configuration and management information back to Azure. Now, what about Kubernetes on Azure Stack Edge? Now, on Azure Stack Edge, under an hour, you can start from plugging your Azure Stack Edge applications to running applications on Kubernetes cluster on an Azure Stack Edge instance. So which is pretty impressive and fast. Now, what does it provide? So with Kubernetes, it provides a couple of important characteristics when you're running that on Azure Stack Edge. So you can scale workloads at the edge for requirements like if you want to scale compute, you can leverage the FPGA or GPU acceleration across the Kubernetes cluster, and you can use the persistent storage that is available on the Azure Stack Edge to scale storage on the Kubernetes cluster you created. And you can build multiple clusters across multiple appliances to improve resiliency. Now, managing this Kubernetes workload that is running on Azure, as I mentioned, is through Azure Portal. We leverage a few things for that, like depending on where you use this Kubernetes cluster and its usage. For example, if it's a Kubernetes cluster that where you use Azure IoT Edge as well, so you can use Azure IoT Edge tools and native Kubernetes tools over local network to manage it locally. And if you want to expose it over to Azure as an Azure resource, the Kubernetes cluster itself, you can use Azure Arc for Kubernetes. Now, when we take a look at the Kubernetes deployment on Azure Stack Edge, which is on a preview, as you can see, inside the appliance, there are master nodes and worker nodes running as a standard Kubernetes cluster. And inside the master node, there's an Azure Arc agent if you want to expose the Kubernetes cluster as an Azure resource in Azure. So inside the worker nodes, it's talking to the relevant Azure services to get that information from. Also, you can use your regular services that you use to manage the Kubernetes cluster. For an example, kubecontrol to the local management of the Kubernetes cluster. You can use that for local management as well. Now, many of the Azure services are offered as containerized edge versions. Things like Azure Cognitive Services, Azure Machine Learning, Stream Analytics, Azure Functions, SQL Database at the Edge, and Azure Event Grid. Or if you want to improve your own service into Azure Stack Edge and run it on a container at the edge, you can write your own or third-party software that is supported to be executed within a Linux container. Now, the final capability we are discussing today is the virtual machines. Now, this is a great option for compute tasks that are not containerized yet, but small in scale. Remember, this is a one new appliance, so it has a limited capacity. So this is designed for basic configurations and can run both Linux and Windows virtual machine. There are some additional features that will be available with virtual machines on Azure Stack Edge to provide high availability and disaster recovery capabilities. Now, for an example, there's capabilities where you can cluster Azure Stack Edge devices. Now, what will this do is it provides clustering the Azure Stack Edge devices so that you can stay reliable or scale up the workloads that requires more than one compute appliance. So basically, if you need more and more virtual machines in a single edge location, you can cluster them. So this is actually a new feature which is coming soon. And these clusters are created and managed from Azure Portal, as you might have already guessed. I mentioned that you can use the Azure Stack Edge as a storage gateway that extends the Azure storage to the edge. What you can do here is you can expose the SMB and NFS shares on your local network, and it literally acts as a gateway to an Azure storage account. You will keep a local cache of your recent files for local access, and all you need to do is copy to a local file share, and Microsoft does the uploads for you. All right. We've talked a lot about the Azure Stack Edge appliance. It's time for some cool demo. So my colleague Christopher Turner, who's doing the demo from his home state while attending to his friends at his home, is going to show you how to work with Azure IoT Edge on Azure Stack Edge. Kris, the stage is on for you.
I'm excited. I'm pretty sure she's excited. And, well, I don't know about him, but she is definitely excited. So, hey, let's get this demo started. I'll see you inside. Today, I'm planning on showing you the power of Azure Stack Edge and what we can currently do with the product. If we have some time, I'll be able to show you some of the future services coming soon that will make this product even better. I'll be building and deploying several custom modules to my Azure Stack Edge I have running at my house. Today, everything I'll be doing is going to be between Azure and Azure Stack Edge. However, some of these new features coming soon to Azure Stack Hub will allow me to truly run everything on the edge. If time allows, I'll be deploying Azure Stream Analytics as an IoT Edge module, which will allow us to take the Azure Stream Analytics logic and move it to the device itself. By processing telemetry streams at the edge, we could reduce the amount of uploaded data and reduce the time it takes to reach insights. The next module I plan to demo enables us to move workloads out of the cloud and onto the edge. This lends itself well to services that process tons of data, like our computer vision module. We'll build a custom image classifier and deploy them to our IoT Edge devices as containers. This can enable us to find insights from images and video streams without even having to transfer the data all the way to the cloud itself. Now, time permitting, I would really want to dig in and get even deeper with the Azure machine learning as an IoT Edge module. The demo will use simulated machine temperature data that will then predict which device may fail sooner than later. I would also love to show you how to deploy Azure functions on the edge that could also enable us to filter sensor data on a simulated IoT Edge device. So let's jump into our demos. Okay, so my first demo, I'm going to actually deploy Azure Stream Analytics as an IoT Edge module. So the first thing that we're going to actually do is we actually need to create an Azure Stream Analytics job. With that, we actually create a storage account. I've already got that done. Then we're actually going to go to and create, of course, a new Stream Analytics job. How do we do that? Well, we do it in Azure Portal. This one is all going to be pretty much portal-based. The next example, the demo I'm going to show, will be more VS Code and how to deploy a module via VS Code. So this one's all going to be pretty much click, and copy and paste. So here we go. We've got, we're going to go ahead and create a resource. We're going to go down and create one from IoT things, Internet of Things, IoT, love that, yep, And we're going to go over to Stream Analytics job. I'm going to wait a few hours here, just kidding. We're going to go to create this name, pretty much simple. That way it doesn't confuse me later down in life. Just going to go to my subscription. Just going to go into a resource group I've already created. I'm going to throw it over in West US 2 because I'm closer to West US 2. It's going to be, hosting environment is going to be Edge, and we're going to hit create. And then we're going to wait a few seconds, minutes, however you want to call it. Now we need to configure this job. So I'm going to go over to our IoT Hub. Actually, sorry about that. I'm going to actually go to our job that we just created. Here we got it. We got our IoT Edge. We're going to first, we're going to add some inputs. Add an input stream. We're going to call this one, of course, it's going to be an Edge Hub. We're going to call this one temperature, lowercase. Everything else is going to be default. We're going to make sure I don't fat fingers these things. This live demo, anything could happen. Although I could hit pause and correct it and make myself look really smart. We're actually going to go back down to outputs, and we're going to add an output. Same thing, Edge Hub. We can actually output data to see what our databases do, but this time around we're going to actually output it to Edge. This one we are going to name our alias alerts, or alerts. I guess you could single player, I don't know. We're going to hit save. And then we're going to go to create a query. This query is predefined in the document that I'm using that you guys could actually use as well to play with these demos. And then I'm going to save query. Now we're going to configure our storage account. Under configure, storage account settings, add storage account. I already have a storage account created. I've got the key in there. And I've created some demos in the past, but I'm going to create another demo that way we have view data. Stream. Hit save. And hit yes. Container successfully created. Now we're actually ready to actually deploy the Azure Stream Analytics Lab to our IoT Edge device. In this demo, we're actually going to use the set modules wizard in the portal. It's going to create a deploy manifest. It's a JSON file, and it basically describes all the modules that we're going to deploy to this device, the container registries, the store, where we store those model images, how the modules should be managed, etc., etc. For this demo, we're actually going to deploy two modules as well. The first one is a predefined, pre-made module. It's a simulated temperature sensor that we're going to quickly deploy. And then we're going to create and deploy our Stream Analytics module as well. So we're going to go to our IoT Hub, which I have right here. We're going to go down to IoT Edge. And then we're going to go and hit, make sure when it loads, we're going to see that here's my IoT Edge device. It's actually my Azure Stack Edge running at my house. You could simulate these by creating your own Linux or Windows machines and having a virtualized Edge solution if you don't have an Azure Stack Edge to kind of play at these demos as well. But we're going to click on this. Currently, I only have one single custom module running, and that's basically a log module that a internal Microsoft employee created that sucks the logs from containers and modules that are running and throws them to log analytics. That way we have an easier way of troubleshooting. So we're going to go up to set module, and we're going to hit add, and we're going to hit IoT Edge module. This one's going to be our simulated temperature sensor. So we're just going to paste that here, and we're going to enter a path to the actual image container that's already created for us. Make sure everything's in there correct. We're going to hit add. Then we're going to go ahead and add our Stream Analytics module. We're going to hit add again. This time we're going to click Azure Stream Analytics module. We're going to go to my subscription. You're going to see that it already exists, the only one that I have currently, and we're going to hit save. Give it a few seconds. I could tell some cheesy jokes if you want. Play the Jeopardy music. Shouldn't take too long here. It's been added. Yay, congratulations. The next step is to actually add some routes. That way we could the modules know where the route data and such. So the routes that we're going to be defining here basically define the flow of the data through the IoT Edge device. It basically takes telemetry data from the simulated temperature sensor, and then it sends it over to the IoT Hub and over to the temperature input. That was configured in the Stream Analytics job that we configured earlier. And then the alert output messages are then sent to IoT Hub and to the simulated temperature sensor module to trigger the reset command, things like that. So I'm going to click on routes here, and lo and behold, they already exist because I'm that great. Actually, I forgot to delete those routes from when I was testing these demos earlier. But now you don't have to watch me copy and paste. How about that magic, right? I'm that good. I mean, I'm so good that it knew to self-populate. Yeah. Anyway, so we're going to review and create. We're going to see the actual JSON file, the deployment file that's going to be created based off of what we just did. In my next demo, hopefully, if I have time to do my next demo, I'm going to actually show you how to actually build these out in VS Code and how to actually deploy from VS Code itself using these JSON deployment files. So we're going to hit create and stop blabbing here. Modules have been set. Now we could see that we have our IoT Edge job module. That's the Stream Analytics module that we just deployed. We also have our simulated temperature sensor module. Everything's running great. There's no exit codes, which is good, because if we had exit codes, then we'd have something bad. The next thing to do is actually show you that this is working. So we're going to run over to, we're going to click over here to Log Analytics. I've got a predefined query that when I hit run, I'm hoping it's going to work. Look at that. Great. So as we can see, we're going to start getting data in, and we're going to get, it's falsified data, of course, because it's simulated data. I don't want to say falsified because, anyway, it's coming in from our simulated temperature sensor. And this is the data that it's sending. And you can see as we get closer, the temperature is rising and rising and rising. When it gets to certain temperatures, that's when some of the alerts that we can configure to alert people, things like that. So I can sit here a few times and keep hitting run, and you can see that the simulated IoT device is actually sending data, and as it should. But at this point, for this demo, this is done, and I'm going to move on to the next demo, hopefully. But I do want to point out what's going to happen here is this is going to continue to rise, right? Once that machine's temperature gets to 70 degrees for over 30 seconds, that's when our Stream Analytics module trigger is going to reset, and the machine temperature is going to drop back down to 21. So in theory, if we keep sitting here, we're going to see some more logs. But I'm going to let this run, and we're going to go on to our next module, which our next module I'm going to try and, well, actually not going to try, I'm going to actually demo how to bring the Azure service, some cognitive services going like custom vision down to Azure Stack Edge as well. So for now, we're just going to leave this and let it run, and hopefully come back and I'll show some of the more logs that where we can actually see the Stream Analytics trigger and do its job. Okay, so my next demo is going to be how to perform image classifications at the edge with our custom vision service. So the first thing we're going to do is I want to talk a little bit about the modules and how things are going to work. I previously did this in another demo where we try to identify sheep versus donkeys versus cows. But today we're going to use kind of a different method here. The first thing we're going to do, of course, is we got our development machine. We got Docker installed, Visual Studio Code installed, a whole bunch of other prerequisites. We're going to be using Custom Vision Service in Azure to train our module, and we're going to then build a module called our classifier, export it, and then Visual Studio build that module, and then push it to Azure Container Registry Service, and then we're going to deploy it to our IoT Edge device, which is our Azure Stack Edge device at this point. And then we're also going to deploy another module called the camera capture module. This one is basically going to, it's a simulator that's going to simulate images being pushed to our classifier. In the rural scenario, you would probably use like a live RTSP feed or some kind of feed that's constantly loading images and things and that source. And then the classifier will ingest those images and classifying debate based off of how that classifier was trained. So first thing we're going to do is we want to actually go in and we're going to build an image classifier using custom visions. We're going to log into our custom visions portal, and we're going to create an actual custom vision project. This has already been pre-created because it takes some time. What I did is I uploaded some stock photos that were provided in a demo from Microsoft Docs, and some of them are hemlock and some of them are Japanese cherries. Each of these folders have been tagged based off of what kind of a leaf or tree they're from, or bush, to be honest. And then we train it. When we're done training, then we could actually export this into a Docker image that we could then drop down into our dev box, and then we can actually build that module that we're going to deploy to our IoT Edge device, which is our Azure Stack Edge. So like once we train, it kind of goes through all the images, and it could pretty much guarantee that not guarantee, but it has a pretty high percentage rate that it knows exactly what a Japanese cherry is going to look like and what hemlock is going to look like. This is where we export. We can export to a Docker file, and then we can go in and go into Visual Studio Code and start creating these modules. Because we're kind of running a little short on time for this demo, I'm just going to walk us through how this was done. I'm going to show you how we did it within Visual Studio. I'm going to run through the process of building the module and pushing the module, and then I'm going to go over and show you what happens in an IoT Hub, and then what actually happens on the Edge device as well. So we're going to come over to Visual Studio Code. Inside Visual Studio Code, you see our project here that we've pre-created. It currently exists. It only currently exists with two modules. We have a camera capture module, which is the module that I was talking about, which is basically a simulator, and we've got our classifier module. The camera capture model, we have a test image that we've kind of pre-fed into it, and what this camera capture model is going to do is it's going to constantly just push this image randomly or to our classifier. And the classifier is going to take hold of this, and using some of its intelligence that we've trained into that classifier previously, it's hopefully going to be able to identify this as being, excuse if I can't remember the hemlock bush or tree or whatever you want to call it, plant. So at the end of the day, we're hoping that our AI and our cognitive service and everything works the way it should be. I didn't do a lot of training provided a lot of photos. So we'll see what happens, right? So one more time, the classifier is the module that's going to classify these images, and then tell us what it is. This is a solution that we could use for identifying traffic patterns, identifying if garages are full or not, things like that. There's a whole bunch of real-world cases behind this, especially if you're ingesting live feeds from live cameras and stuff. So once we have this built, these are Python modules. You could have C#, you could have Java-based modules, but these two modules are basically Python modules. Excuse me. We have an environment finder that kind of basically tells us the password and the username for our container registry. And then we have some deployment templates. The deployment template for this one is pre-created. We did have to do some editing. I'm going over this really fast. One of the when I deploy this deployment template, anything that's on my Edge device right now is going to be wiped, and so I'm going to lose all my modules that I currently have on there. So I wanted to make sure that I'm keeping that logging module on, so I could dump logs over to Log Analytics. So I kind of edited this deployment template myself and added the path to the gentleman's container image. And of course, we added the routes in here, so we don't have to manually add them in the portal. Once we deploy this, we're actually going to come over and we're going to actually build and push an IoT Edge solution. So what's going to happen is it's going to build these two modules locally using creating Docker images. Then it's going to push those Docker images over to ACR. When that's done, we can then go back. It's going to create a config file for deployment. Then we could deploy the solution to whatever Edge solution we have, be it an Azure Stack Edge device or Edge running on Azure Stack Hub, or just Linux test system itself. Really wish I had a little more time for this one. This one is pretty nice because it goes into more detail, but just at high level, just to get your feet wet and to understand how modules are built using VS Code and how they're deployed. Maybe some other time we could do a whole hour-long session on and go more into detail here. Also using Azure DevOps and CI/CD pipelines and how to create and push and maintain your modules as well. That would be something very nice as well. So we don't got too much time. So what I'm going to do is I've already actually deployed a lot of this stuff to kind of save us some time. What I'm going to do is kind of do an example. I'm going to go here, build and push an IoT Edge solution. In theory, it's going to push, it's going to build the images using Docker, and then it's going to push them to ACR. But since these are already built and already pushed, wow, magically they're there. So now we want to deploy our solution, and we're going to deploy it using our deployment manifest file. It's pretty simple. There's various ways you could do it. You go down to the Edge device that you want to push it to, or you could actually just go up to the config file that's been created, right-click, create a deployment for a single device, or create a deployment at scale. So let's say you have 1,000 Edge devices spread across different oil fields or different corporate farms or whatever you want to call it, and you wanted to send out a module that was going to go out to each of them. This is when you would deploy at scale. For me, we're going to do a single device. It already has been populated, knowing which IoT Edge device I'm going to be using. We click on it, it starts the deployment. Deployment is successful. We come over here to our IoT hub here. And then we're going to go down to IoT Edge. We're going to refresh. This is my, I'm going to refresh this. This is going to be my Azure Stack Edge. You'll see that it's running okay, which is always good, especially after pushing deployments. That's very good. You see that now we have my 3 modules that are running. We have our log spout. I have my classifier and our capture image. Those are running. There's no errors reporting, which is always it's always a good thing. Usually this takes a few minutes and it's going to override itself. So hopefully when we go to look at these logs to find out what is going on, that and to see if the classifier actually works, that everything's happy and hunky-dory, right? So let's go to our log analytics workspace. We're gonna look up the log real fast because I don't remember the query offhand to find this out for me real fast. Okay, this is just gonna give us a whole bunch of data. I'll worry about it in a second. We should be seeing some information from our here shortly. Got some old data here. So live demo, well, sort of live demo. I've been sitting here waiting for data to come and come and come. So I'm going to troubleshoot here, which I kind of already know what the problem is. Basically, there's some settings that I didn't change in my deployment JSON for the specific module that's pumping the logs into log analytics. And how I could actually kind of tell that. We're going to go back to IoT Hub. I'm going to go down to IoT devices, actually, no, IoT Edge. We're going to click open our Edge device, and we're going to click over our log spout. And we're going to figure out that, yes, this is the problem. So I've got an old workspace ID and a old secret from an old configuration that I copied over. So I'm going to go and fix that real fast. And to do that, we're going to look into our file here. So as you can see, this is my deployment template JSON. Here is our modules that we're going to be deploying. That this deployment would deploy. Under create options, I copied and pasted what she did from an old deployment that I used in a different demo, and it's pointing to a different log analytics workspace, and that's why it's not working. So we're going to go and fix that really fast. So I'm going to magically change this. Well, not magically. I'm going to do it live. Well, as live as I can get. Right. And hopefully nothing will break. Nothing more than it's already broken. And for you guys that are trying to be sneaky, this workspace will be deleted before long, so it won't matter if I show you that information. We're going to save our file. Now that we have the correct information, we're going to deploy this manifest, delete this manifest file here, just because I want to. Then we're going to right click. If I do a build and push, it'll kind of do the same thing, or I could just generate an IoT Edge deployment manifest, which is what I'm going to do here. So it's not going to actually build anything and push it at this point because we don't need that. I'll come up here. I'm going to create a deployment for a single device again. Choose my device. It's going to deploy to my Edge device, and then deployment is successful. Now if you go back to our portal, and it's going to repush everything, so it's going to take some time before other stuff is ready and before that data starts coming in. I can sit here and tell some jokes. What do you call a dairy cow that isn't producing milk? A milk dud. Thank you. Anyway, quick little tidbit here. So I've logged in via PowerShell to my Azure Stack Edge, and then I'm able to actually see some of the images running on there. And as you can see, the log spout is the most recently deployed, which means it should have its new settings, and we should be able to see that it's what we desire versus what it has. Should match up with our current log analytics, which looks pretty much correct at this point. So at this point, we're going to go back over to our log analytics workspace and our logs. We're going to just run a simple search, and hopefully I didn't waste our time. And then we actually have some logs that are coming in. Sweet. There we go. We got some updated logs coming in. Now what I want to do is I want to get logs and see what's coming in from camera capture and also what's coming from the classifier as well. So I'm going to run the logs one more time here. And now we'll start seeing some logs coming in both from the camera capture and the classifier. As you can see, the camera capture sent a total of 16 images, which is the same image we've had, over to the classifier, because that's always, it's a dumb little summation. It's going to always send that over. The classifier is going to grab that image, crop it, try to read it, use some intelligence to try to see what that is, and then it's going to compare it to what we trained it. So we're actually going to look for something like this result here from the classifier. This is going to tell us what the classifier, what the intelligence thinks it is. So as we can see, the prediction that it thinks, actually the prediction is that it has a high probability of it being hemlock, which I'm pretty sure that was a hemlock leaf or bush. So at this point, we have enough intelligence that this module, this classifier, knows that this is a hemlock image, and based on what we need to do with this image is, if it's not a hemlock image, it can be uploaded to some other storage, Azure storage devices, either on Stack or on Azure Stack Hub, or even in Azure itself, and then other services could take advantage of the data now as well. So in the long run, we ran out of time, so I can't show you more demos. I wish I could show you some more, but we did the 2 demos. We did the first demo with the stream analytics. And we also did the demo of this one here with custom vision, both being located on our IoT Edge device, which is actually our Azure Stack Edge device. and having pretty much the Azure services running on our edge device to be able to help us manage the data, manage our images, manage anything that you can think of before we send that data up to the cloud or over to Azure Stack Hub for other tools to take advantage of. So in a nutshell, that was my first 2 demos. I just want to thank Janaka, and I want to thank Dave and Crystal from MVPDays for letting us have this opportunity to show you a little bit about Azure Stack Edge and things that you could do on Azure Stack Edge and Azure Stack Hub. I truly hope those were not very bad demos. Do you get it? Sheep, bad. Anyway, sorry. Thanks again. Hope you had a good time. Hope those demos are worth it. Thank you. Bye.
Thanks for that amazing demo, Kris. We always value your feedback, and we highly appreciate that you joined this session today, and we hope to see you in another episode of MVPDays conference. Stay tuned, and thank you, and have a lovely day.